Hello, I'm Yusuf. Today I'll be presenting our paper No Culture Left Behind. This is a collaboration between KAUST, Northeastern University and the University of Oxford. I would like to start with the Bender rule, which has been criticizing the community for assuming English is a representative of all languages and NLP. This is evidence where 63% of ACL publications in 2008 targets English language, with this percentage increasing recently. However, we know the majority of our world population does not speak English. According to Cochrane, 75% of people do not speak English at all. In this work, we introduce ArtELingo-28, which is a multilingual effective captioning dataset collected from native speakers. We provide the annotators with an image and ask them to select 1 out of 9 emotions, as well as write an effective caption. The effective caption describes the image details with an emotional language, and it focuses on the emotional aspects of the image. Here we can find differences in the annotations of 5 languages. The 5 annotators experienced different emotion labels. They also focused and commented on different parts of the image. We believe these differences are not random. In this work, we demonstrate how culture and language are predictive of these differences. Here are the languages that we collected. We collect 2,000 images in 25 different languages. You can download our dataset from here. We will start by introducing our dataset and show how it is one step in the direction of leaving no culture behind. Finally, we will show our experimental setup results where we demonstrate how culture influences emotional perception. ArtELingo-28 is a natural progression of image captioning, from describing facts in COCO to providing effective captions in ArtELingo-28. COCO captions aim to describe the objective facts in an image. It did a great job at combining vision and language modalities. Next, Artemis came and it enriches the captions with emotions and commentary. It aims to describe the subjective details of an image, and it managed to capture the interplay between emotions, language, and vision. Unfortunately, both COCO and Artemis were collected in English. The need for multiple languages is essential to understand the diverse cultural views, especially in case of subjective descriptions such as Artemis. ArtELingo took a step in that direction by collecting captions in Arabic and Chinese. This example shows how an Arabic annotator feels satisfaction with this image since it has some trees that can provide shade, while both English and Chinese annotators who are used to lush forests view the image negatively and associate it with dead trees. Based on this experience, we believe that adding more languages would make us see more interesting structures. So as we mentioned, ArtELingo did a great job including Arabic and Chinese. However, this accounts only for 36% of the world population according to Ethnologue report. To embrace more views, we need to collect more languages from native speakers. Our dataset ArtELingo-28 fills this gap perfectly. We collected effective captions for 2,000 images in 25 different languages, all collected by native speakers, and now our dataset covers 65% of the world population. We have 140 annotations per image, reflecting diverse opinions and world views, compared to only 15 annotations per image in ArtELingo and 5 in Artemis. Our dataset covers 28 languages, all collected from native speakers, compared to just 3 in ArtELingo and English in Artemis and COCO. Due to the difficulty of hiring annotators in all of these languages, we collect our data for 2,000 images only, amounting to 200,000 annotations. We now show how ArtELingo-28 embraced diversity and different cultural views. We collected our dataset from native speakers of 28 languages. Our dataset demonstrates how culture influences visual and emotional perception. This example here highlights the difference in emotion labels and caption content. We show an image with 5 captions from 5 annotators speaking different languages. We observe a difference in emotion label, where the Malay annotator has feelings of awe, while the Burmese annotator reports emotions of disgust. The difference goes beyond the emotion label. Here we see the isiZulu caption describes the background and the lady's dress, while the Korean and Setswanian caption focuses on the face and hair. Finally, the Burmese and Malay caption is related to the bodily parts. We use Amazon Mechanical Turk for our data collection. Our interfaces are based on ArtELingo. We restrict each language collection to countries natively speaking that language. Our dataset covers 7 different regions. Africa has 10 different languages. Southeast Asia has 5. We have 4 sub-Indian continent languages, 3 from the Middle East, 3 from Central Asia, while 2 from East Asia, and English to represent the Western culture. Here are all the languages. Chinese, Arabic, and English were imported from ArtELingo. Our goal is to collect 10,000 annotations in each language. We collected all the annotations for some languages, while others are not there yet. ArtELingo-28 took the huge effort of 228 annotators with a team of 32 coordinators checking the annotations quality, ensuring the high quality of our data. This amounts to more than 6,000 annotation hours and 2,500 hours for quality control. We now move to the cross-lingual tasks and benchmarks. The first one, we have an effective caption generation task, and next we will show the emotion label prediction task. In effective captioning, we feed the model an image, an emotion label, and a language. We then ask the model to generate a caption in the provided language that describes the painting under the context of the input emotion. Since multilingual captioning models are limited, we train our own vision LLMs with a multilingual large language model. In particular, we use PlumeZ, which supports more than 40 languages. We have 3 different experimental setups to evaluate our model in practical scenarios. In zero shot, we simulate the situation where we have a large dataset in a few number of languages and study the model's ability to perform cross-lingual transfer. We train on Arabic, English, and Chinese from ArtELingo. Then we evaluate on all the 25 new unseen languages in ArtELingo-28. In few shot, we measure the model's improvement as we increase the number of fine-tuning instances. We fine-tune the pre-trained zero-shot model on the 28 languages in ArtELingo-28 and evaluate on all the data in ArtELingo-28. In one versus all zero-shot, we study the pairwise language interaction. In ArtELingo-28, we use the pre-trained zero-shot model and fine-tune it only on one language, and then we evaluate on all the other languages to see which languages transfer better to which other languages. We train 5 models: Instructable, ClipCap, MClip, and MiniGPT4. Use PlumeZ, while we train CCLM from scratch. We report Blue, Meteor, Roach, and Cider metrics. Here we can see MiniGPT4 performing the best on all metrics. And here are some examples. Generation. Arabic and English were seen in the dataset, while Hindi and Spanish were unseen during training. You can see the high quality captions. In the few shot, we fine-tune the zero shot MiniGPT4 model from 20% to 100% of the ArtELingo training data. And we report the same for metrics. MiniGPT4 learns very quickly and reaches very good performance with 20% of the training data. Finally, in one versus all, we fine-tune on the source language and evaluate on the target languages. Interestingly, we find cultural groups emerging out from our data where nearby countries perform similar to each other. For example, the green cluster here, we can find Urdu, Hindi, and Tamil grouped together, even though they are all written in different scripts. And here we can find the African languages spoken mostly in Southern Africa, and also all of the African languages are grouped together. Finally, we can see the Central Asian languages grouped as well. In our second task, we have emotion label prediction. We input a caption to an XLM Roberta model that predicts an emotion label. We study the efficacy of training on 28 languages. We compare 4 models. The base model is pre-trained on 900,000 samples from ArtELingo. This has Arabic, English, and Chinese captions. ArtELingo is further fine-tuned on another 200,000 samples from ArtELingo, but they are different from the initial 900,000 samples. ArtELingo-28.0 is pre-trained only on 200,000 samples from ArtELingo-28. Finally, ArtELingo-28 is pre-trained on 900,000 samples from ArtELingo and then fine-tuned on 200,000 samples from ArtELingo-28. We report the accuracy, precision, recall, and F1 score. Here we can see that ArtELingo-28 is the best performing model, reflecting the importance of multilingual training. In this video, we presented to you our dataset ArtELingo-28. We have shown how it embraces diversity and different world views. Through our experiments, we showed how culture is predictive of dataset differences. Please download our dataset and models from our repository, and thank you.